In this video, is a second method continue from the previous video where I discussed for the same question, but now I'm using another alternative tool in solving this and finding this equation of the circle. Alright, in the previous video we have using the general equation by finding the value of GFC by solving the simultaneous equation. So we can find the value of G, F and C, right? Then we get the general equation of the circle. So in this video, I'm going to show you another method, right? Another alternative method here, where as you learn in your school day, in your secondary school, where your teachers will tell you to using geometrical instrument, right? So to drawing the chord within these 2 points, right? The chord. Then from here you can build the, you can construct the perpendicular bisector, right? The perpendicular bisector that passing through the chord will divide them into 2 equal parts. But the most important that along the perpendicular bisector, they were passing through the center of the circle, right? So, and we need another point, right? As you know that center of circle can be anywhere around here, right? So to get exactly where is the center of the perpendicular, the center of the circle, so we have to need for another chord, right? For example, this case here. So I draw another chord here and I draw a perpendicular bisector. Means I'm using geometrical instrument. I built the perpendicular bisector that passing through this chord, which is also divide this chord into 2 equal parts and 90 degree, right? And 90 degree here. So eventually these 2 lines will meet at the circle, which is the intersection point. It's the intersection point between this line and this line. Alright, so after we have the center, we definitely with this center and either one of the point, we can find the radius of the circle. Alright, this is another method that I'm going to show you how to doing this by apply the concept of the perpendicular bisector. 2 perpendicular bisector intersect at the point, and that point is actually the center of the circle. Okay, let's see how to solving this. Alright, okay, let's start with I'm building the first chord, okay, between these 2 points here, right? And I know that I will construct, I will know somewhere there is a circle, the center here. Definitely the perpendicular bisector will passing through the center of the circle, right? But okay, first I have to, because I know that if you have this one, you have find the first perpendicular bisector, and for this you have find the second perpendicular bisector, and of course I need the equation of this line, right? As perpendicular bisector is a straight line, so I need the equation for the first line and the second perpendicular bisector to solving the simultaneous equation and getting the center of the circle. This is the concept here. So of course, since this is a perpendicular bisector, I can find the midpoint, right? I can find the midpoint between these 2 points. So I can just I can label this as A, this is B, and this is C, right? So I'm going slowly. So you just see what I'm doing. So here will be, I label this as M, and M is the midpoint between A and B, right? As you know that the perpendicular bisector will divide this into 2 equal lengths, right? So to find the coordinate M, right? Coordinate M, I just using the concept of midpoint, -2 plus with 1, -2 plus with 1 divided by 2, right? This is the way of finding the midpoint. Let's revision, right? -1 plus 8, -1 plus 8 divided by 2. So I will getting the coordinate of M to be -1 over 2, right? -2 plus 1, -1 over 2. And this you have 7 over 2. As this is the point M, the coordinate point M. So I will not writing here as you refer to here. So then this line will passing through. So of course the first objective here will be finding the equation of this line, right? Equation of this line here. So I want to find the equation of this line. I need to apply the straight line, the concept for straight line, which I need the gradient, right? the gradient of this perpendicular bisector. Before that, I know that I have to calculate the gradient of MB, the gradient, right? Gradient for the line AB. So by using y1 minus y2, the formula for gradient. So as you know, the formula for gradient will be y1 minus y2 over x1 minus x2, right? So I'm going to find the gradient between these 2 points. So where I'm taking the 8 y1 minus with negative 1 divided by 1 minus with negative 2. 1 minus with negative 2. So which gives me 9 divided by 3, which is 3. If I already know the gradient for AB is 3, and you know that this is perpendicular, this perpendicular bisector is perpendicular to AB, right? So how to find the gradient? So as I know that the gradient, let's say the gradient for this, I label it to be M. The gradient multiply, as the knowledge for geometric coordinate, you know that M multiplied with the gradient of AB, which is 3, will give you negative 1. Why? As we apply the concept of M1, M2 is equals to negative 1 if the line L1 and L2 are perpendicular, right? So alternatively, we can know that the gradient for M will be negative 1 over 3, right? Means the gradient for this line is negative 1 over 3. So you have the gradient, and you have the line is passing through this midpoint, right? The midpoint here. Because the line is passing through this midpoint and you have the gradient, you can finding the value of, you can finding the equation of this line. Let's label this equation of this line to be line 1, right? L1. Equation of L1. Equation of line number 1, the first perpendicular bisector. So I will using the formula for either you can using y equals to mx plus c, or you can using the formula for y minus y1 equals to mx minus x1. So either two is okay. So you have y equals to mx plus c. So as you know, the gradient, the m will be negative 1 over 3, right? Negative 1 over 3x plus with c, right? The gradient for this line you have already found to be negative 1 over 3. So, and you have to find the y-intercept, but you know that this line is passing through the point M, right? Which is you already found just now is negative 102 and 702. You can substitute this into the line because as this point is on the line. So then you have 7 over 2. 7 over 2 equals to negative 1 over 3x. X will be negative 102, right? Negative 1 over 2 plus with c. So simplify, so we have 1 over 6 plus with c, and which give you the value of c to be, there we get 10 over 3. So rewrite this, we have y equals to negative, okay, I just writing here the equation of line L1 to be y equals to negative 1 over 3x plus with 10 over 3. So this is the equation for line number 1, or the perpendicular bisector, the first perpendicular bisector. So, but we just knowing that this perpendicular bisector, they have a center on this perpendicular bisector, but you need another perpendicular bisector in order to find the center of the circle. Alright, I show you again how to find another perpendicular bisector from this circle. Alright, okay, let's find another perpendicular bisector by joining B and C. Right, B and C. So we know that if there is another perpendicular bisector for this line, if we construct, they will definitely passing through the center as well. As two perpendicular bisector, the meet at the point. This is the center of the circle, right? So again, we're finding, I can just label this as N. We can finding the midpoint for this chord here. So where N, finding the midpoint, so we're taking 1 plus with 1 plus with negative 6 divided by 2, right? 1 plus with negative 6 divided by 2. 8 plus 1 divided by 2. So we're getting the midpoint, right? The midpoint between for this point B and C. So which will give you negative 5 over 2, negative 5 over 2, and 9 over 2, right? 9 over 2. So now we have know the coordinate of N. So of course we need to find the gradient, right, of this line here, because we want to find the equation of line L2. Okay, I label this to be L2, the equation of line L2. So to find the equation of line L2. So very simple. At first we're finding the gradient between these 2 points, right? Because we don't have this gradient, but we know this line and this chord and this perpendicular bisector is actually perpendicular to each other. So the gradient for BC, right? The gradient for BC, which is y apply the formula for gradient, 8 minus 1, 8 minus 1, y1 minus y2, 1 minus negative 6, 1 minus negative 6, right? So you are getting 7 divided by 7, which gives you the value of 1, right? Okay, 8 minus 1 is 7. 7 divided by 1, you're getting 7 also. So you divide, you're getting 1. So as you know that the gradient, so I label this one just now, this one to be M1 and down this one to be M2, right? M2 for line L2. So M2, you know that the gradient for BC multiply the gradient for M2 will be negative 1. Why? Why is it? Why is it? Because this line and this line are perpendicular, right? According to the knowledge of geometry that you learned during additional maths, you know that the gradient for this and the gradient for this, if you multiply, you're getting negative 1. So, and you know that the gradient for BC is 1 multiplied with M2 to be negative 1. Then easily you can get the gradient for line number 2, right? For line 2, right? We have the value of gradient of negative 1. So how we can find equation of L2 by applying the knowledge for straight line. We can either apply this formula or we apply this formula, y minus y1 equals to mx minus x1. So in my video, I applying this. So you can try by using this formula also. So then I have y equals mx plus c. So as I know, the gradient for the line 2 will be negative 1, right? Negative mx plus c. To finding the c, we have to look at the midpoint, because as this line is passing through the point N, right? Which is the perpendicular bisector. We'll divide this into 2 equal parts, and this will be the midpoint between these two, right? So as just now we have already found that it will be this is the midpoint. So we'll be substituting the value of y 9 over 2, right? 9 over 2 equals to negative x, right? X will be negative 5 over 2 plus with c, right? And we're getting 9 over 2 minus with, as this become positive 5 over 2, bring it over, become negative 5 over 2 plus c, equals to c. So c, 9 minus 5, you have 4. 4 over 2, you have 2. So finally, we have get the equation for line number 2, right? Line 2, which is y equals to negative x plus c, which is 2, right? So this is equation for perpendicular bisector, right? The second perpendicular bisector. Alright, finally we have already find the two equation of the perpendicular bisector. right? Which is these two. So as you know that these two perpendicular bisector, eventually they will intersect at the center of the circle. So our target is to find the center of the circle. So I have a solved simultaneous equation between these two, right? It's the intersection point between these two will produce the center of the circle. So we just take, because when they intersect, the value of y will be the same, right? So I can say negative 1 over 3x plus with 10 over 3 equals to negative x plus 2, right? Equation 1, equation 2, just replace the y with this, right? So then we're solving this, we were getting negative 1 over 3x plus with x and 2 minus with 10 over 3, right? For this, you are getting 2 over 3x, which is equal to 2, 3, 6, right? 6 minus 10 over 3, which eventually will giving us negative 4 over 3. And the value of x here will be negative 4 over 3. This go over there will become multiplied with 3 over 2, which will give us negative 2. The value of x will be negative 2. So again, we want to find the value of y, right? The y. So we can substitute either into equation 1 or 2. So I can substitute equation 2, easier. So I substitute, I'm getting y equals to negative x, which is negative 2 plus with 2, right? Negative x, negative 2 plus with 2, which will give us 4. After we getting the value of x and the value of y here, what's actually is this, right? This is actually the center of the circle, right? The center of the circle, which gives us the value of x, the intersection point, right? Which is negative 2, 4. The x is 2, negative 2, and the y is 4. So which gives us the center of the circle, right? Okay, the method here will be, for this method here will be, we are using two perpendicular sectors to finding the center of the circle. Alright, now we have already found the center of circle, and definitely we can find the radius of the circle, right? Let's see how to find the radius of the circle. Alright, let's continue with finding the radius of the circle, right? So radius circle, we can actually joining this center to any point on the circle here. Alright, I can joining between this point and this point, right? So the distance between this point on the circle and the center will be the radius. You can either using the center with this point A, point C, or point B, right? It's either one. So I will say that the radius will be the distance between center and, right? The center and the B, right? And the point B here. So so to find the center, so the formula will be square root the distance, right? Distance. The formula for distance between 2 points will be x1 minus x2 to the power of 2 plus with y1 minus with y2 to the power of 2, right? So I will taking 1 minus with negative 2, 1 minus with negative 2 square, x1 minus x2, x1 minus x2 divided by 8 minus 4, right? Plus with 8 minus 4 square. So we're giving me 3 square, 9, 16, so which is 25, which give me 5, right? Which give me the radius 5. So for this case, if you're using this method, it's easy for you to finding the standard equation of the circle, right? Because you have already know the center, right? The center is negative 2, 4. So apply standard equation will be easier, as this is your h and this is your k, right? So your x minus with negative 2, right? H square. We're applying the formula of x minus h square plus with y minus k square equals to r square. The standard equation will be easier in this case. So plus with y minus with negative 2, right? Y minus with negative 2. So it means that x minus h square plus with y minus k square, y minus 4 square equals to 5 square, r square. So you were getting x plus 2 square plus with y minus 4 square equals to 25. This will be the standard equation for this circle. It's also the equation of the circle. If the question 1 requires you to find the general equation, you can just expand this and write in the form of x squared plus y squared plus 2gx plus 2fy plus c equals to 0. So in this video, I'm just showing you how to using this concept of chord and perpendicular bisector to finding the center of the circle. Hope you understand.